Hey everyone, and welcome back to the minigame project series. Just like every video, I'll be diving into the realms of web development and gaming magic. In our journey, we're getting a hands-on experience with jQuery, which is like the Swiss Army knife of web developers. You might be wondering, why lean on jQuery? I mean, it's still used by like almost 80 million sites and WordPress plugins and things like that. It can help cut through some complexities, has a lot of cool shorthands we could utilize. It has a lot of cross-browser compatibility, and it just gives us something new. I know that word is ironic with jQuery to do in our development process. It's walked the path, it's battled the dragons, and it's returned victorious. And it's able to share a treasure trove of tricks and spells with us, with a very, very long history of things that you could Google search, forum threads, Reddit threads, YouTube video, everything, right? It's everywhere. So it's going to be easy to research and work with. I go over it more specifically in the README of this project, which you could find in the description down below. It'll be a link to our GitHub repository for it, where you can clone the latest or the previous commit in order to follow along with me in the middle of this web series, so you don't have to go back to the first video. Although if you are stumbling upon this, I do suggest you go back and watch the first video. I do a bigger introduction on why I'm choosing to go this way. You know, I wanted to change it from my normal CRUD, MERN, stack projects and all those variants. I didn't want bundling and build tools and process. I wanted simple HTML, CSS, and JS, just like you see in the File Explorer over there, and all the scalability and organizational issues that might entail. I want to practice something kind of fundamental, which is why I wanted to do this project series here. So yeah, gear up. Let's dive on in. We're going to pick up with Tic Tac Toe, where we had just left off, implementing a very simple AI computer player into the project here, right? So what we're going to be doing is, like I said, we're going to pick up where we left off from there. Am I in the wrong OBS window? I am. There we go. So from this, like I said, you can find the repository in the description down below. I also typically link the jQuery cheat sheet as well as any other like assets or tabs I open up. I always try and link in the description down below to help y'all out to quickly find this stuff, so you don't have to pause and wonder. But if you do see something that I utilize that you didn't quite catch or you can't read in a pause of the video, let me know in the comments down below and I'll be happy to respond. Like I said, we left off with Tic Tac Toe. We implemented the ability to switch with these button groups. I'm still leaving advanced for a separate video, but we're not too far off from that. I have the classic, just two-player mode, a play against the computer mode, where we have a computer making totally random moves and still managing to beat me somehow. For example, right here, I just beat the computer because I was just watching what it did randomly until I could make a win. Because again, it's just looking for empty spaces and playing randomly. So how about today we do some clarifications, some optimizations, some cleaning up of our code a touch, and we'll talk about how we can begin coding a slightly better AI. Now, I did tell my coworker Andrew he needs to make a video series where he actually builds like a Node Express or a Go Fiber or something like that server. I don't care how he codes it. Just code a server of some kind that has, like, for example, an OpenAI secret key that he stores in environment variables that will make requests to GPT with their secret key, maybe sending a screenshot or the game state to GPT. GPT will make the next move, send it back, and then we send it to the client, which will then update the computer's move to make a near probably unbeatable AI. But we're going to be not doing that route here because that'll introduce a lot more complexities that I need in this project. So instead, we're gonna try and implement a slightly smarter computer, because like I said, at the moment it just does the most random possible move. Find an empty space, generate a random move, play that move. That is the entirety of our computer's quote-unquote AI. So instead, what it needs to be doing is it needs to say, hey, can I, I was going to draw this with my mouse, but I realized it's going to be a lot harder to write than just in like a code comment. So, what we're going to be doing now is the following, basically. Let's write some quick pseudocode here. So the computer needs to make a move. So we're going to say computer turn, let's zoom in, Luke, so people can actually read what you're doing. Computer turn, this is what we're going to be focusing on. First things first, rather than making a random move, the computer has to look at the state of the board and ask itself, can I win with the next move? Can I win with my next O? If so, play that move, right? Then it wins. If it can't win with its next move, the computer then has to ask itself before it makes a random move. It goes, okay, well, if I can't win, can my, I can spell, opponent win with their next X, right? Then we have to make sure the computer can say, oh, the player is about to win because they have 2 in a row, whether that's in a row, a column, or diagonal of some way. If they got 2 in a row and a blank space, that means that the player can then beat me the next move, which means we gotta block that. So it has to block ourselves from winning. That way it actually has some strategy implemented into its computer turn. And then if those 2 conditions fail, we're going to have the computer make a random move anyway. So we're going to utilize the logic we already have. We're just going to implement some checks beforehand as well as some utility functions to help us get there. But this is what we're going to be focusing on in this video. Writing a way for the computer to determine if it can win. If it can, then, well, it wins. If it can't, then can my opponent win with their next move? Because if they can, we have to prioritize blocking them. Otherwise, if those 2 things are not true, then we just default to making a random move as it currently does anyway. So that's going to be our pseudo logic for the game. And like I said, we're going to implement some cleanup across the game here. So let the games begin. All right. Something that will help players, especially like I have students that have done this on our normal lab of Tic Tac Toe in our curriculum, in our full stack curriculum, which again, check the description down below for a link to our community membership, access to our courses, all the content, Discord, constant updates, new courses, all that fun stuff is a link in the description down below for our community membership, which will include a Tic Tac Toe lab. So a lot of students will do the classic if, else if brute force statement. A lot of them will have it cleaned up by checking against the current player that will have all possible conditions. And from there, they have these like hard written checks here for checking rows, columns, and diagonals for wins and things like that. But we can have some additional or a lot more clarity if we add in a scalability in the sense that if we ever decide to make our tic-tac-toe grid bigger, which is something I see my students that go above and beyond in our course do to the lab, going, well, here's the traditional tic-tac-toe, here's advanced mode, which is a bigger hashtag, like pound sign, which will require like 4 in a row or 5 in a row. Like they'll increase the size of the board, increase the number of conditions for the win, or checks for the win, and the code can get pretty nasty without some utility behind it to make it cleaned up. So we can say, for example, function is winning line. We can have a nice little optimization for clarity here that will pass in 3 possible conditions or more if you're going to go for a bigger tic-tac-toe game, which is this is a best way to do it. It's going to return a comparison to say, hey, is the position in A, whatever cell that happens to be, top right, bottom left, who cares? Like, it doesn't matter what cell of the game it is. This is going to simply compare, are these 3 values similar? So it's going to say, hey, not current mode, current player. There we go. Is A equal to our current player? Because if they are, that's good. If A is also the same value as B, and if A is also the same value of C, if all 3 of these conditions together are true, that means we have 3 X's or 3 O's in these 3 cells. Again, this is agnostic to where they actually are on the board. It just takes any 3 cell values and tells us, hey, that's a win, or hey, it's not a win. So we're going to get a truthy or falsy value returned out of this, and we can now utilize that to clean up inside of here. So instead of having to do all these comparisons, I just need to know the 3 positions inside the set of parentheses. And I'm going to utilize those set of parentheses there and some commas separating the parameters now, and wouldn't you know it, we have a much cleaner looking condition check for checking our rows and columns. I can do the same cleanup right down here. Separate my parameters with commas, utilize those parentheses that are already there, format, boom, look at that. We have a very clean condition check here. And again, once it begins expanding, if you wanted to add that as a feature, this is a much cleaner and better way to do so. Again, I'll have my students be like, hey, why don't you have like a check line or check something function a lot of the times when they do their version of tic-tac-toe in our course. And I'm like, well, it really just depends on your skill level. how much you're looking this thing to grow, etc., etc. This is a preference thing and not a requirement. It's overkill for my current setup because it worked totally fine beforehand, but I wanted to throw that out there to give us yet another way of cleaning up our code, encapsulating some logic away from here. It cleans up like the actual logic of checking and winning the game. And all it does is report to us a true or false value on this condition, saying, hey, if the values of the board or the cells we're passing in all match up in a row, that's got to be a win. And that gives us the ability to now write these quicker and cleaner down here when we begin adding more rows and columns to like our advanced board, for example. If you have a slider that can grow or shrink the board, this will make it a lot easier to conditionally run out these is-winning line functions, and it'll get a lot cleaner. So yeah, I mean, that's pretty straightforward and simple in terms of like small optimizations before I begin actually going into the more advanced logic. I don't want this to be like another hour and 20-minute ass video. We'll get there when we get there. But yeah, something else we can actually include that I realized I talked about but didn't actually fix, which is like the stacking of these click listeners, where one bound click function has the job of modifying the DOMs and its CSS, and the other stack listeners on the buttons purpose is to actually start the game logic. You know, I mentioned this is a fine way to do it, to keep things separated. We are stacking multiple clicks on elements using this approach, which can have a lot of issues when you're trying to debug and figure things out. I think the mouse wheel on my mouse is busted, because sometimes when it scrolls, as you can see, it flickers before it actually goes up, and I have to like very specifically scroll up. And I've been noticing this recently when like traversing or just like Reddit threads or comments and like scrolling on the screen, and then the flicker constantly happens because I think something is wrong with my mouse wheel. It's driving me nuts, and I wanted to include it in this video so y'all can suffer with me. So now you're going to notice it when I'm scrolling, and you notice it flickers as it scrolls for some reason. Anyway, like I said, another small optimization is basically taking the logic out from over here where we have the multiple. We're going to have these 3 click listeners for the individual buttons, but we can actually combine a lot of them into a function that takes care of the DOM class and the game change at the same time, to give our actual bound click listeners an even cleaner looking piece of code. Again, just another small optimization, and again, to encapsulate as much logic as we can into my Tic Tac Toe game object, right? The function, the immediately invoke function expression, the IIFE that we set up in one of the first videos, returns to us along with a public API. So again, I'll have one called function change game mode. It will pass in a single parameter, which will be whatever new mode the button is going to be representing. And we're going to do the logic that says, well, yeah, I can just copy paste, couldn't I? I can copy and paste what our button click currently does, which is say, hey, in the buttons in the button group, because again, there'll be multiple buttons on the page. Remember, we had this discussion last time with the reset game button not being included in this. I will say button classes inside of the button group class selector. Find all elements that have class button and remove class active if it exists. Now, we can't do the this.add class active anymore, unfortunately, but we do have something else we can go around that. But anyway, remember, at the end of the day, initialize game is how, or start rather, is how we made these buttons start the new mode of the game. But now that I'm inside of my actual game object, I do have direct access to initialize game, and I can simply pass in my new mode that way. Remember, because we now have our initialize game function able to take a mode we pass into it in order to play the game. So this right here is going to have to change. Remember, as a refresher from the last video, my what's it called? My buttons have a ID on them that is ID selector mode dash and the game mode classic advanced computer that correspond to this frozen object right here that I could utilize. And all I have to do is grab its value or whatever new mode I pass in, because I'm passing in its value down here. We pass in the value of the game mode as a parameter to this function. All I need to do is change it so they all run instead. Change game mode, pass in that parameter, and I have access to new mode. So new mode will be capital letters, for example, computer. And we know that one of my buttons that I'm clicking on, for example, has hashtag or rather ID mode dash computer, except computer is lowercase and not uppercase. So imagine we can just hit it with one of these to simply to lowercase the name of the new mode. And instead of having it hard coded to be computer, this would be our new mode variable. And from there, as you can imagine, all I'd have to do is wrap it in a set of backticks. That way it is actually read as a string value. And then all I would have to do is wrap that in a set of $ curly braces. Remember, that's not jQuery, that's string interpolation inside of template literals, where I will ask it to interpolate the new mode value that we're passing in, lowercase it as a string, and then simply attach it or, concatenate it or interpolate it to the ID selector mode dash. This is how, instead of, as we can see the $ parentheses, this jQuery, because it no longer will know what this is, it'll simply be, hey, find the ID of the button that corresponds to the new mode and add a class of active to it. So this is, again, a small optimization that gives us some cleanup that will now be available down yonder. So I can remove this click selector binding because I don't need it anymore. Reset game will be the same. Now we could do some shorthanding here with arrow functions if we wanted to. It can get pretty clean with these things being repetitive with arrow functions. Either way, it's fine. They all have this on click listener, but now all I have to do is change it to change game mode instead of start. They're going to pass in their exact same parameters, arguments, whatever. Does this clean up decently with the arrow functions? I mean, it should. We get rid of the function keyword, leave those parentheses, now add an arrow function in front of the parentheses and behind the curly brace. I can technically ditch this leading curly brace because if I do an implicit one-line return, this should give me some cleaner looking code. Delete those ending curly braces, move the parentheses up to the last line or the line of the code. If I hit format, what does it do? Well, it new lines it anyway, but okay. Yeah, that was an attempt to try, because of the way I have my prettier formatter set on my code wrapping, it doesn't move it to one line. But this is an implicit one-line return. We just happen to do the one-line space after the arrow function here, so it is an implicit one-line return that we are doing here. So there is some clarity or less syntax clutter. If you like this, now attached to each button, they all call in this new function called change game mode that will handle the DOM manipulation and the starting of the new game mode. Oh, and I need to add it to the public API, because I was wondering why it was not highlighted. That is because just because I'm calling it down here doesn't mean it's available in scope, so I had to make sure it is on my Tic Tac Toe game object that we've been coding on here. So I now have change game mode as a possible little optimization that we have from the previous video series to make sure that the game mode is still changed as is, right? So as you can see, there's no change here, but if I click back on Classic, everything still flows the exact same way. The button group gets highlighted with that active class, everything works, and we've now cleaned up our code a good little bit and removed an unnecessary click handler that was added to all of my button groups, because I've now housed it into a singular bit of logic. And this is a clever little trick that you will see me do pretty regularly in code, and I realize it's something that my beginner students tend to always overlook or underthink, or maybe overthink, thinking it needs to be fancier than it is. Nah, dog. Grab a string, lowercase it, make it match your IDs, and you're good to go for some dynamic selecting. I think that's pretty nifty. I think that's a cool way to do it. Okay, so now we're going to get to the slightly more complex bit, which is, and probably the bit everyone's actually here for, how do I make my computer run some better logic, right? We have make computer move right here, and guess what? We're really not going to change anything in get computer or make computer move. It will still be the random move that it's going to make if there is no other strategy it needs to employ first. So I'm going to collapse it for now because, again, the last video was all about that. So we're going to add a new function called make smart computer move. It will take no parameter, and it's going to do like our logic was before. Find if O can make a move and win. Make O winning move. Then it's going to try to find if X can make a move and win, which will then make X blocking move, right? That's the logic. Once again, just to reiterate, I don't know why I'm doing this again, considering I talked about it at the top of the video. Otherwise, just make regular, random move is all it's going to have to do. So there's a couple different ways we can tackle this. I can write out the logic of what it's going to look like right away, and it might make more sense if I do it that way, and then I write the function, because I'm going to have to write another utility function that will do this. It needs the finding of the O and X. We could code directly in here, but it's going to get messy, and just like I showed y'all with check winning or find winning line, a little utility function can really clean up some otherwise complicated feeling logic, especially if you want to add more strategy later. So we're going to have another function called find winning move. And with find winning move, it is going to return something to us, right? It's going to return something to us, and it needs to know, again, what player, because we don't need to make two different functions for seeing if the computer win versus can the player win. At the end of the day, all it needs to do is go through the current state of the board and say, hey, is my current player that I'm being fed, X or O, do they have two of their symbols in a row with a third empty one next to it? Because if that's the case, that is a winning move for that player, and I can return and I can find out what that winning move is and return it. Or if there is no winning move, I can just ask this function to return, for example, null, because it says, hey, there is no winning move, because again, otherwise it will return what the move is, which might be like, hey, x1, y2 is the winning move. So that's what our winning move syntax is going to look like. It'll be an object with an x and y position, which will correspond to my game data cells that we've been using, data x and data y, right? So again, at the end of the day, it will return an object that will correspond to what the winning move for that player is. This is just a hard-coded example. If no move can be found, it should return something that we could use in a conditional statement. I'm going to choose null because, again, might return an object, but null means there is no object. And null evaluates as falsy in JavaScript. We're going to be leveraging that. So before I finish coding winning move, I wanted to show y'all what that looked like, as well as what its example returns are going to look like should it find a winning move, which will allow me to now make the smart computer move function basically fleshed out and give y'all an idea of how this is going to happen. So we're going to do a let designation for the move variable because we're going to be reassigning it based on some conditions. So first things first, find a winning move for O, right? See if the computer can make a move and win, right? Because if it can, rather, and hello, Percival. Always when I start this video series, this cat comes crawling around. Come say hi, buddy. Don't be shy. He's booping the monitor, acting all cute like he wants attention. Hi, Percy. Yeah, he's thrilled. Okay, so rather than just make a random move, which it will make the winning blocking move if available. If no winning blocking move, do random. So we're going to do a slight variation on what my pseudo logic was. Of course, sorry about that. If it calculates it doesn't have any moves, just make a random move. If it finds an O move, it won't find an X move. It won't do a random move. It'll make the move if it's available if it gets down here. Meaning we're going to turn allow cell click back on to true because it needs to make a move. And what it's going to do is simply call its own our own make move function that will be passing in. Remember, move represents what this function down here returns, which is an object of two properties, x and y. We're going to call it move.x, move.y, as well as the cell or cells that it represents, or the cell that it represents. So the cell that it represents is a little bit complex. We're going to do a jQuery selector with a string interpolator right here, these template literals rather, because we're going to interpolate some code. And as you already know, I can tell you that it'll be move.x and move.y that we're going to be interpolating. But we're going to have a lot of stuff written around that. So remember, in the make move function, it corresponds to the cell we're making a move on. So how do we uniquely identify one cell from another? It is going to be with the pair of its two data attributes. Again, my example was x1, y2. So let's find that. x1, y2, that is the right-hand side column, middle row. So if this is the cell that x1, y2 corresponds with, we can write a CSS selector that can be given to jQuery for clarity that says, hey, find class cell, and remember we talked about this in previous videos. This is not just a jQuery thing, this is a CSS thing that our jQuery selector gives us a very easy way to handle, although query selector, all in vanilla DOM these days does that. It didn't back in my day when I only had get element by ID. We can pass direct matching values with name equals value attribute selectors, aka the things I need for my custom, because cell is not unique enough, but I can say, hey, find data-x and make sure it has a value of 1. Also, find it with data equals y-2, so I can make it match 2 attribute values, 2 attributes, and 2 direct values together. This is how I'm going to uniquely find what I need to select. And now I can take that little pseudo snippet right there, that little comment from the HTML, and go back yonder to paste it in here and comment it out so y'all can see what I'm building. All I have to do is honestly take this, paste it here, take the interpolation of move x and replace the 1, because again, the 1 represents the x value, whatever it happens to be. Take the move y and move it in the place of the 2, and as you know, the double quote positioning around the move x, move y interpolated code is very important for it to properly run the CSS selector. But there you go. If it does actually return a move, then make move will just make that move if that's the case. But let's say it returned null. There is no winning move whatsoever. What does it need to do? Well, we can say if move, and remember, if it's null, the opposite of null is true, or true, right? Opposite of null, which is falsy, means it's truthy, which means it will run this, stop the code here, do not go down to make that winning or blocking move, because it needs to just do its normal logic, which we currently have in place, which is make a random computer move anyway. Make a random move like before. This makes the winning blocking move if 1 is available. As the way we have it currently written, it always returns null, which means this move value will be null. Opposite of null is truthy, because null itself is falsy in JavaScript. And make computer move will then correctly run. I can't see my Windows taskbar, and I'm afraid to Alt-Tab incorrectly. There we go, because the cat is in the way, as always. We should go back to the computer board here and make sure it still works as is. Nothing has changed in terms of logic. It just returns that null value, and this isn't doing anything, Luke, because make smart computer move is not being utilized anywhere. Now, is it, you dummy? Well, we can actually, JK LMAO, we can go up to, let's see, it'd be on our click listener. Yeah, it'd be on our click listener up yonder. So instead of make computer move, let's change it to make smart computer move. And we got to make sure that it works, right? So let's go back to computer, confirm. Okay, the game is still just playing as is with random moves. The second test was the correct test. My bad on that one, y'all. That's what I get for trying to pick up a cat, look at my code, and talk about my code all at the same time. Mistakes happen. All right, make smart computer move is still now doing exactly what it should be, which is making a random move if these cases don't actually work, right? All right, so like I said, continuing on with our little pseudo code here, it'll never actually generate a move as of yet, but it's good to actually go ahead and write it this way. Let's say it didn't find a move for O and can't win for O. Then it has to see if X is a possible move. So we're going to say, hey, reassign move if it finds one for X. Now, this is what is the cool bit. It allows us to use that same find winning move function for winning for the computer or blocking for the player. Because there you go. That's all it needs to do. Right? It makes the O, or this would be find if it can block X, right? That's what this is doing. And then it makes the winning or blocking move just down here if it gets that far. Right, so that's really all there is to it. I can remove these comments because, I mean, that's what this code is. It's very, very straightforward in terms of logic once you understand what find winning move is supposed to do and how it's going to work, right? See if it can find a win for O. If it does, that means it's truthy, skip this, allow it to make a click, and make the move. If O returns null, meaning the computer can't win, then it says, hey, can the player win? So if this has null, opposite of null is truthy. This will then reassign move based on if X can win or not. If it's null, it comes down yonder and says, okay, O can't win, X can't win, make a random move. If it returns a move, it's truthy by the time it gets to this check. It then skips that and comes down here and makes the move to block X. And that's all there is to it for that logic. Like I said, the more complicated part here in this video is going to be the actual logic to find, because there'll just be a lot of like checking back and forth and writing code for how to do that. So we know at the end of the day that it needs to basically loop through all the rows, all the columns, and the two diagonals and ask itself, in any of these winning positions, which there are 8 total, right? Because 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so there's 8 winning conditions of the game and the way we've coded it. And all it has to do is go through every possible winning condition and ask itself, are there at least 2 moves for this player in that condition? If so, and the last spot in that condition is also empty, right? So it means like, hey, if we're looking at the top row, does 0 have an X in it? Does 1 have an X in it? Or that could also, by the way, be, hey, 2 and 1 or 2 and 0. It doesn't matter what order in that row. That's the other thing to remember. It doesn't matter what order of the row. We're looking at top row for X, for example. It doesn't matter what order these cells are in. I just did 0 and 1 because that's the easiest way to visualize it. Like, again, it could be 0 and 2 as well. That's a valid one, right? The outsides in the middle is empty. So we have to say, does that combo have 2 in a row? And is the third spot an empty string? If that's the case, that can be a win for X, and then it's going to have to return what that spot is, which would be returns X of 1, Y of 0, because it's the top row, right? No, I just realized that okay, I'm talking about the top row and the column. So yeah, the position would be, my goodness, row 0, column 2. There we go. I knew that. Right? Yeah. Oh, I completely overthought that. But there you go. That's what it'll return. So it's going to have to track what row and column it's in so it can actually calculate the move, but that's what's going to happen. It goes, okay, there's 2 in a row, and we also have an empty spot. So we got to return what that empty spot is, because that's where the move has to be made. So how are we going to do that? We're going to do that with our good friend, as always, the for loop. And the for loop is going to be responsible for basically check rows, check columns, and outside of that, we're going to write our check diagonals. That looks right. Diagonals individually, because they won't work inside the loop there. But yeah, the loop will be fairly straightforward. We've done it before. Let I equal 0, I is less than 3, I plus plus. Remember, it goes from 0, 1, 2 for the columns and the rows. All we got to do is loop through each row and then basically the column in the reverse direction. So what we're going to do here is say the following. Check the rows. If board I. Now here's where it gets kind of clever, I thought. We need to look through board I, because remember, this is rows. If I add a second set of parentheses or square brackets, that's column. But we don't care about that. We just care about the row. So this will tell us what each row is. And remember, the state of the game was this syntax. So board 0 gets us the first array. Board 2 gets us the second array, and board 3 gets us the third array. So that is how we're looking at the code here. 0, 1, 2. That's what it represents. Well, if each thing is an array of 3 potential string values, all I have to do is filter out the player we're looking for, or filter in the player we're looking for. So I can say, if the row which is board square bracket I, which is another array. If we run a filter method on that and say for each cell of the state of the game, we run the following function for some, implicit one-line return for code clarity here. If each cell value is equal to our player, and if their player is X, and again, the array would be the following if this was the case. It'd be X, empty, X. That's what this represents right here. 0, 2, and 1 is empty. That's what that represents right there. So if that's what our row looks like, we filter each cell, which that's what these represent inside of here, cell, cell, cell. If they equal the player, give them to me, which means it'll empty out the empty string. If I have an array of 2 X's from my filter, that has a length of 2, which means, hey, there's 2 in a row for this row, this column, or this diagonal. Aha! Check the length of that array to see if it equals 2. Because if it equals 2, that means we got ourselves a possible winning combo. Before the filter, remember, we're looking at this. After the filter, this is what we get. Okay, there's 2 X's. And again, this is what's brilliant about this solution, because if it was written this way instead, we filter out the 2 X's and still get an array length of 2. If the winning combo we're looking at is the following, the other way around, it also doesn't care. Filter out the empty, get the 2 X's. We got 2 in a row. That's a possible win. But there's one more thing. What if I have an O in one of those empty positions? So all I have to do is now also say, hey, if I have 2 X's or O's, doesn't matter now, in a row, I also have to check that array to see if it includes an empty string rather than another X or an O. So that's the logic. If it includes an empty string. So does the filter give us a length of 2? Okay, it's a potential win. Now, see if the array also includes an empty string. If it does, that is a winning move for that player. If it does not include an empty string, for example, if it includes an O instead of an empty string, then we can skip it because it has no available move in it. And that's it. That is all we have to do to check all of our rows. Because remember, this will go through each array in our board of rows, filter through for the player. If that gets us a length of 2, that could be a win. And the last place also includes an empty string. That's a winning move. And we have to simply stop everything and return the move from this function. And that's it. So the clever way we're going to do that is, like I said, we have an X. I'm going to hard code zeros as placeholders. Now the X, what row? Well, that just is easy here. It corresponds to the value I, because remember, I is going through each of our rows inside of our board game state. The Y is a little bit more complex, but still not that bad. We figured out up yonder that if the board includes an empty string and the other player is a length of 2, we have an empty spot left to play. So all we have to do is find the empty spot of that empty string. And we can do so very easily by simply referencing the row and getting the index of that empty string. And there you go. That is how you find if a row or a row rather has a winning move inside of it that it may need to block or win. So that's all it did right there. Okay. Now the check columns is going to be a little bit more complex since it doesn't correspond directly to our list of subarrays that the rows did for us. But there is an easy way that we could also make this loop-like, in the sense that it's going to be in the loop. We just have to make an additional, we don't need to, but for clarity, I'm going to make an additional variable for my sanity. Let's find out what each column is, because at the end of the day, the columns are going to correspond to exactly the same values as our board does, obviously just in the vertical. So what does that mean? Well, then we're going to, no, not 0, my bad. The I goes there, the I goes there, the I goes at the end there. So now we have our dynamic columns going across. And all I have to do is tell it specifically top left, middle left, bottom left. Then it will go to the next loop iteration, which will grab us top middle, right? Because it'd be row 0, column 1. Then it's row 1, column 1. Then row 2, column 1. Then the loop iterates again, and it'll be finally 0, 1, 2, 0, 1, 2, right? And so the I's correspond to that Y data position inside of each of our subarrays, right? So we had to do a little extra work to find what the column is here, but it will now still loop through just like it will for our rows. We had to simply code what the column is based on the value of I. So like I said, if I is 0, that's top 0, 0 is top left, 1, 0 is middle left, and then 2, 0 would be bottom left. And then I iterates to 1, that's the middle column. I iterates to 2, that's now coded to be the right-hand side column. And there you go. We got it figured out. We need to do something very similar in our if statement here for our that we did for our row, which will be, hey, column, I need you to filter each of your cells and find me if they match the player. Because if that's going to be a match, we have 2 in a row in that column. If that length equals 2, that means we got a potential win for that player in that column. And y'all guessed it, if the column includes an empty space as well. So we're going to say if the column includes an empty space as well, and it has 2 in a row for that player, that's got to be a win for that player in that column. And we're going to do the same thing, return an X, hard placeholder. The Y is for the column value, so in this case, it corresponds to the I, the dynamic part of what column space it's in. And the X will be wherever in the column the index of the empty space corresponds to. And voila, we now have our rows and our columns configured to be checked for. So now we're going to pass in a player. It is going to check to see if that player has a winning combo in any row, a winning combo in any column, and return what that winning combo is with the last empty space to either win for the computer or block the player. But like I said, we can't do that quite as nicely with our diagonals, so we're going to have to code them by hand outside of the for loop and write each one individually. So I'll say const diag1 equals an array of my boards that will look like this. Very similarly, I'll have to just hand write each one myself. I should have just copied and pasted, whatever. Oh, I can't. Prettier, and we'll do diag2. Okay, so there we go. There's the we're making another array. We're making 2 custom arrays to utilize my array methods of index, of, includes, and filter again of the columns themselves. So top left, then we have to do the middle because they're diagonals. The middle will be the same on both of them. And now I need the bottom right, which is 2, 2. This will be the / diagonal. So we're going to have the top right, which is 0, 2, the middle cell, which is 1, 1, and the bottom left, which is 2, 0. So now I have my 2 diagonals. All I got to do is run either 1 or 2, depending on what you want, if statements. I don't really care which way you do it. That will, just like before, return what that winning move happens to be. So in this case, we'll do diag1.filter. Each cell in the diagonal I have now hard-coded. If that cell is equal to our current player, if that gets us a length of 2, and our diagonal 1 also includes an empty space in that array, you guessed it, we need to return where that empty cell is, and that corresponds to wherever this is in the diagonal. Now, because the diagonal doesn't have like a nice iterator like our for loop does, for both X and Y, it'll be the same thing. In the diagonal 1 we're currently looking at to see if there's a winning combo, return the index of that value. I could also, y'all know, make this into a variable and write it into both. For now, let's go ahead and write it like that because it's the same thing, right? All it's going to do is return the index of that empty space in the X and the Y direction, or the X and the Y column, because again, it's coded for my diagonal here. And honestly, all I'm going to do is copy and paste this down to the bottom one here, change diag1 to diag2 in all these positions, and it should be good to go. Let's double check for any mistakes here. Filtered, length equals 2, length equals 2, length equals 2. Just making sure I didn't do something dumb along the way, which is a possibility I did. But yeah, that's all that smart computer move does. That's all it should need to get the job done. Let's see if it works. I think we are set and ready to go. My prettier is telling me there's a problem though. Oh, no, there we go. Sorry, I have a prettier extension that I use and a JSON file on my computer that I can set my prettier formatting to globally on my machine. It can be annoying when I work on smaller scope projects or team projects, but whatever. If I have like a syntax error somewhere and I try and hit my format hotkey, I get that red thing in the bottom right corner of my VS Code window that tells me that I am missing some syntax somewhere probably, which again, mistakes happen no matter, even with all of VS Code's amenities of like auto closing, parentheses, and curly braces and whatnot. Still make mistakes, that's fine. If I see that red, it's a very clear indication to me I have a syntax error somewhere, but I have to actually hit my format hotkey for it to go away, which is why I thought I had a problem. Okay, again, these little things that are like tools that are not meant to, like, it's not meant to tell me there is meant to tell me there's a syntax problem. It's just a good visual indicator I got a syntax issue. Okay, I think we're good. Let's actually go test this sucker and see if the computer is now way more difficult to beat, because y'all saw earlier, all I did is just start going for any combo I could, and the computer would make a random move, and I'd work around the random move. But now the computer has strategy, meaning it should attempt to block me. So we're going to test it a few times to make sure we don't just get a lucky fluke. Random move. Okay, I'm going to go for the diagonal. So if I click this diagonal, it has to play here. If it doesn't, we know something's wrong. Let's go. Ooh, look at that strategy. So now, if I click anywhere other than blocking the computer should make a move there and win. Let's see if that's the case. All right, it just won. It won pretty handily. Let's reset the game. Do the same thing. Okay, that's where it randomly made. Let's see if it blocks me. It did. Let's see if it blocks me here. It blocked me again. I need to block it, but it's got me. This got beat. If I play here, I block it. If I play here, I block it. But either way, it wins. Yeah, there it goes. Oh my god. All right, let's see if I can beat it here. Okay. It had to block me. That makes sense. Yeah. Blocks me again. Oh, I didn't play this very well, did I? Oh, well. The computer clearly got stuck. That's interesting that it got stuck there. And I wish I could recreate what just happened so we could figure out the logic of why that happened. Hold on. Block me. All right. Well, clearly something is now bugged on my reset because it did not. The computer is not currently playing through. So we got to figure out what is possibly going wrong. Because now, as you can see, I'm now playing for O, which is not supposed to be the case. Hold on. Something is goofy here. There's X. There's O. I play here. It blocks me. Okay, so something is clearly wrong when it gets to the computer's turn. And it has to block me more than once. So, all right. We got to debug why it is failing. Okay. So what is the conditions that is causing this? I mean, clearly I can recreate it, right? Because that's fine. It blocks. I play. It blocked me there. I know what it is. Hold on. Yeah. All right, so I missed the tiniest thing that I even highlighted in my notes, and I just zoomed through it, and it's right here on the y-axis of diagonal 2. Get in the comments if you if you have like a better, I don't know, geometric and mathematical background than me and already knew this is going to be an issue. So, let me, where did my pen tool go? Let me pick a better color. So, the problem that happened is as following. Right, and hold on. The problem is with this diagonal. Because the calculation we do for the other diagonal, which I'm going to mark in pink text. Right, I know there's overlay, bear with me. So In this diagonal, it completely corresponds to an array of positions, right? If those are, I mean, I know they're O's, not X's. Get off my back. I need to get all the way off my back about the symbols here. The point is, the array in the left-facing or backslash diagonal, the index positions correspond to the appropriate position for the cells themselves. But that is not the case for the forward slash diagonal, right? Because technically the position of that 0 in the array, right? Position 0, so if I calculated x0, y0, because again, the code is based off of the empty string position. So if this is the empty string value, 0, 0 corresponds to up here and not down here. The row calculation is correct of 0, but the column calculation of also 0 is incorrect. So what we need to do is take in only this diagonal, take the y coordinate and subtract 2 from it to get the actual position. So if it generates a 0, 2 minus 0 gets us 2, which will be actually the bottom left here. If it's a position 1, 2 minus 1 gets us 1, which would be 1 comma 1, which is right here. And if we get element array index 2 as the empty string, that'll be 2 minus 2 for the y position, which will be 0, which is the column up here. So that's the issue. It is a math calculation issue that I goofed on. I made a note not to forget it, and I did it anyway. We need to take this value and simply subtract 2 from it. That was the bug. The bug was when it needed to actually draw a block in the forward slash diagonal column, it calculated the incorrect x and y coordinate, and if it was blocked, the computer got stuck and couldn't make a move, right? That's it. We simply have to find the correct position of the column because of the angle of that forward slash not corresponding to our column, or our diagonal rather, which is an array value, our diag2 in particular. That's that forward-facing diagonal. The array index positions of the empty string are fine for the row they appear in, but not for the column. We have to take that and simply subtract 2 from the column value in order for it to correctly calculate where that goes. So it was the forward-facing diagonal that was a problem. Now it works just fine. And as we go along through the game, once again, the draw function works. Can I actually beat this thing? I don't know. Like, I've made it almost near unbeatable. The next thing to do to make it near unbeatable would be to actually have it strategize. So instead of just making a random move, it would have to make a random move and what's it called? I mean, yeah, this is dumb. Again, we're just gonna end up in draw territory forever. But yeah, it would need to make a random move, not just make a random move, but actually strategize, going, hey, so let's go back to a simple example. So at this point, if I make a move that doesn't wind up in a win, it just makes a random move. So if I click here, it's like, okay, I'll make a random move, which it did. However, what it should do is go, hey, is there any direction where I can place my player tile, an O, somewhere in that it gives me a winning move in 2 steps? So it'd have to check for a condition, an empty row or column or diagonal that says, hey, I have a length of 1 already there and 2 empty strings, so I'm going to place my player tile, whatever it happens to be, in one of those conditions if I don't have a winning move. So right now I would calculate its winning move is down here. It has to block me here. I don't want to sit here and play forever and drag out this video because I'm almost at an hour long when I said I didn't want it to get that long. But yeah, basically it played the move there, and let's say I make no winning move here, it will generate a totally random move. But what it should do if I place the move there, so if I place here, if I place my X here, it has no winning move for itself. It has no blocking move for me, so the computer will then make a random move somewhere in the game. But instead, the strategy should be, oh, I have an O in the bottom row, which means I can place an O here or here, and get a potential win as the next strategy, as the next move. So that would be the next step if you wanted to go further, which I don't think I will because the game logic's going to get pretty gnarly. But if you're interested, get in the comments or implement it yourself and share it with us on a repo or a code pen of your own to show us the additional strategizing steps you take to make a near unbeatable computer, right? So at the moment, if I get lucky and it doesn't pick anything in the top row, we can force it. There we go. I got it. Now we got to win. Yay, we beat the computer, y'all. Okay, so there you guys go. Guys and gals go. We have a computer that actually has and employs a strategy beyond just making a totally random move. It actually strategizes to win for itself or block us first. And if you want to go any further, it would be implementing the logic of like, okay, let's set up our own winning move instead of just making any random move. But there y'all go. Do the YouTube stuff. Like, comment, subscribe to our channel, like this video, like I said, and check out the description down below for a link to the README and all the link to the cheat sheet I use, this repository, and all that fun kind of stuff. The README will always be the most up-to-date place where you can find information on the game, and my dumb ASCII art I always include in my projects. Link to the playlist in the description. Also, link to the individual videos are here in the README as well. So get involved, and hope you enjoy what we're doing so far, because I'm actually having a blast doing game development, because it's outside of my wheelhouse, and it's been fun for me to learn and try and digest it and share it with y'all. So I'll see y'all in the next video, where I think we might start... Oh yeah, we still have advanced mode, don't we? We're going to work on advanced mode that has like some cooldowns for our players playing against each other to use. So yeah, I'll see y'all there.